Hello everybody, welcome to this new seminar class of the Rule Governance course. In this week we will cover ontology and institutionalism. What is ontology? Etymologically, ontology is the study of what exists. We don't take here a nihilist position towards what's out there, so we do assume that there is something out there. However, an ontology could exist only of purely informational entities. If it is a study, this means that's a conceptualization, and the conceptualization is an account of entities that can and are distinguished. If we were not able to distinguish them from something else, we could not conceptualize them. The word analysis, in fact, comes from the process of separating something into its constituent elements. If we think again, however, concepts are generally not about instances, that is, individual objects that are in our focus, but about the types of these entities. We need to add to our account of things also those types or classes. If Plato is thinking of a horse, he is not thinking to a specific horse, but is thinking to the idea of horse that he has in his mind. Psychologists would rather say that he is thinking to the prototype of a horse, or a data scientist would say to the mean or perhaps the median of the horse latent space, but this is another story. For what matters, here we distinguish the class or type of entities from the actual entities, instances of that class. The analytical method applied on what appears to our experience has resulted in several ontologies. The first graphical ontology known to us is the tree of Porphyry, 3rd century after Christ, who, although being a Platonist, constructed it starting from Aristotelian categories. However, we will not do here a course of ancient philosophy. What is important for you to know is that ontologies are today also computational artifacts. Ontology engineering is in computer science and information systems the field that provides methods and tools to create and use computational ontologies. They are computational in the sense that they are machine-readable, and so they can be used by computers to reason or make any other form of processing. They are ontologies as they specify or attempt to specify shared conceptualization. Pay attention though. We have objects, situations, events, as that stone which is now falling on Aristotle's foot. We have things said about objects or situations of events, as the ouch said by Aristotle. And we have things thought about objects, situations, events, as Aristotle's thinking of the ball falling. Conceptualization is clearly a fundamental part of modeling, how we conceptualize something, how we specify the conceptualization of something. These are two different things. The conceptualization resides upon humans, at least in this context. We are not referring to machine-learned latent spaces. Humans can verbalize them in a way that can be further processed by machines. Note also the distinction between specifications used for modeling, that is, aiming to describe things which exist out of there, for instance, old kitchen tool one might observe, and specifications for design, that is, aiming to prescribe how things should be done, for instance, recipes or blueprints, etc. Sometimes both aspects coexist. Data structures for programs are primarily ontologies or schemas used for design specification, but often they have some correspondence with the real world. For instance, a user object stands for a computational counterpart of a real human user. So, this is our central point here. Ontology, that is, an explicit specification of a conceptualization, is something you can build. Several tools are available. You could write a database schema, a class diagram in UML, Unified Modeling Language, use formal logical definitions, write down definitions in a standard specification or in a regulation, or writing a shared vocabulary or glossary of terms. The last three are written in natural language. The first and the third have a rigid formal semantics. The second one is kind of half and half. Now, what ontologies serve to our purposes? We have business processes, and business processes run or maintain activities. Those processes implement services provided to some service consumer, but they as well call and reutilize other services implemented by business processes. A business process can be seen as an implementation of a function which is described as service level. Typically, business processes need to follow the rules. That is, their activities are circumscribed by law. In other words, we can check whether they are compliant or not. Additionally, services, business processes, activities are described by means of some concepts. These concepts are events, transactions, objects, agents, but also objects describing potentialities as the competencies or abilities of the agents or other similar dispositions. In order to model everything, these concepts need to be defined somewhere. We can therefore distinguish a regulative part and a definitional part associated to some business. Now, the norm model we use to check compliance represents something which has been interpreted from sources of law, but at the same time, some of the definitional components are part of the source law. For instance, in contracts or terms of services, there is usually a starting part that says definitions. However, not all concepts are defined in the source of law. Some terms refer to some common sense meaning, which is extra-institutional, and thus refer to a word model. I can, for instance, say that in the context of part regulation, a bike is a vehicle, but we still don't say what is a bike, and this is given as known by the reader. Okay, now to go more into practicals. Let's look at perhaps the simplest way to specify parts of an ontology. Class diagrams are typically used to identify the data structure or informational model of a certain application. If you've had some experience with object-oriented programming, it should be easy for you to recognize this. However, they can also be used as a modeling tool, as providing an account of things. This figure is an example of an actual class diagram, used while developing an application. The yellow post-its are just comments, so you don't need to look at them. The concepts are in the boxes, for instance, person, folder, agent, work, document, etc. The arrows define the relationships between boxes, between concepts. For our purposes, we will highlight two relationships. The is-a relationship, the arrow with the empty triangle. Is-as is a subsumption or taxonomical relationship. A dog is an animal. In this diagram, we have a person is an agent, a group is an agent, a virtual fragment is a general fragment. The second relationship is as-a, or the operation of aggregation of partonomy. An agent is part of a group. A group has at least one agent. A work has some document, here in the sense of expression. A document has some textual fragment. There are also some other relationships. For instance, an agent owns a folder. A reference has a subject fragment and an object fragment. Sometimes it is also useful to distinguish between aggregation and composition as weak, strong arrangements. Two living forms in symbiosis form an aggregation, or better, they are loosely coupled, but in principle one of them can be replaced with another one functionally equivalent. The same holds for mechanical devices. For instance, the wheels of a car are objects independently of the car. Wheels are assembled with other objects to form a car. Before transplants were possible, organs could not be replaced from an organism. The organism is not an aggregation of organs, but a composition of organs. Organs do not exist without an organism. If the organism disappears, so are organs. In our study domain, we said we consider two dimensions. The first is the regulative one. The ontology here is about normative concepts and other normative constructs. It could be, for instance, part of the concepts expressed in Sartor's paper, or the implicit ontology on which any normative frame language is based upon. But we have also concepts about business processes and service domain concerning transactions, agents, and competencies that can be described by class diagrams. In a way, normative directives are superimposed on scenarios of the world, and therefore these concepts need to be defined to understand what these norms actually mean. The exercise of this week will be about making these connections clear.